Chapter 9 of Book 2 of On the Heavens by Aristotle, translated by J. L. Stocks. This LibriVox recording is in the public domain. Recording by Geoffrey Edwards. Chapter 9. From all this, it is clear that the theory that the movement of the stars produces a harmony, i.e., that the sounds they make are concordant, in spite of the grace and originality with which it has been stated, is nevertheless untrue. Some thinkers suppose that the motion of bodies of that size must produce a noise, since on our Earth the motion of bodies far inferior in size and in speed of movement has that effect. Also, when the sun and the moon, they say, and all the stars, so great in number and in size, are moving with so rapid a motion, how should they not produce a sound immensely great? Starting from this argument, and from the observation that their speeds, as measured by their distances, are in the same ratios as musical concordances, they assert that the sound given forth by the circular movement of the stars is a harmony. Since, however, it appears unaccountable that we should not hear this music, they explain this by saying that the sound is in our ears from the very moment of birth, and is thus indistinguishable from its contrary silence, since sound and silence are discriminated by mutual contrast. What happens to men, then, is just what happens to coppersmiths, who are so accustomed to the noise of the smithy that it makes no difference to them. But, as we said before, melodious and poetical as the theory is, it cannot be a true account of the facts. There is not only the absurdity of our hearing nothing, the ground of which they try to remove, but also the fact that no effect other than sensitive is produced upon us. Excessive noises, we know, shatter the solid bodies even of inanimate things. The noise of thunder, for instance, splits rocks and the strongest of bodies. But if the moving bodies are so great, and the sound which penetrates to us is proportionate to their size, that sound must needs reach us in an intensity many times that of thunder, and the force of its action must be immense. Indeed, the reason why we do not hear and show in our bodies none of the effects of violent force is easily given. It is that there is no noise. But not only is the explanation evident, it is also a corroboration of the truth of the views we have advanced. For the very difficulty which made the Pythagoreans say that the motion of the stars produces a concord corroborates our view. Bodies which are themselves in motion produce noise and friction, but those which are attached or fixed to a moving body, as the parts to a ship, can no more create noise than a ship on a river moving with the stream. Yet, by the same argument, one might say it was absurd that on a large vessel the motion of mast and poop should not make a great noise, and the like might be said of the movement of the vessel itself. But sound is caused when a moving body is enclosed in an unmoved body, and cannot be caused by one enclosed in and continuous with a moving body, which creates no friction. We may say then, in this matter, that if the heavenly bodies moved in a generally diffused mass of air or fire, as everyone supposes, their motion would necessarily cause a noise of tremendous strength, and such a noise would necessarily reach and shatter us. Since, therefore, this effect is evidently not produced, it follows that none of them can move with the motion either of animate nature or of constraint. It is as though nature had foreseen the result, that if their movement were other than it is, nothing on this earth could maintain its character. That the stars are spherical and are not self-moved has now been explained. Chapter 10. With their order, I mean the position of each, as involving the priority of some, and the posteriority respective distances from the extremity. With this, astronomy may be left to deal, since the astronomical discussion is adequate. This discussion shows that the movements of the several stars depend, as regards the varieties of speed which they exhibit, on the distance of each from the extremity. It is established that the outermost revolution of the heavens is a simple movement, and the swiftest of all, and that the movement of all other bodies is composite and relatively slow, for the reason that each is moving on its own circle with the reverse motion to that of the heavens. This at once leads us to expect that the body which is nearest to that first simple revolution should take the longest time to complete its circle, and that which is farthest from it the shortest, the others taking a longer time the nearer they are, and a shorter time the farther away they are. For it is the nearest body which is most strongly influenced, and the most remote, by reason of its distance, which is least affected, the influence on the intermediate bodies varying, as the mathematicians show, with their distance. Chapter 11. With regard to the shape of each star, the most reasonable view is that they are spherical. It has been shown that it is not in their nature to move themselves, and since nature is no wanton or random creator, clearly she will have given things which possess no movement a shape particularly unadapted to movement. Such a shape is the sphere, since it possesses no instrument of movement. Clearly then their mass will have the form of a sphere. Again, what holds of one holds of all, and the evidence of our eyes shows us that the moon is spherical. For how else should the moon, as it waxes and wanes, show for the most part a crescent-shaped, or gibbous figure, and only at one moment a half-moon? And astronomical arguments give further confirmation, for no other hypothesis accounts for the crescent shape of the sun's eclipses. One then of the heavenly bodies being spherical, clearly the rest will be spherical also. Chapter 12. There are two difficulties which may very reasonably here be raised, of which we must now attempt to state the probable solution. For we regard the zeal of one whose thirst after philosophy leads him to accept even slight indications where it is very difficult to see one's way, as a proof rather of modesty than of overconfidence. Of many such problems, one of the strangest is the problem why we find the greatest number of movements in the intermediate bodies, and not, rather, in each successive body, a variety of movement proportionate to its distance from the primary motion. For we should expect, since the primary body shows one motion only, that the body which is nearest to it should move with the fewest movements, say 2, and the one next after that with 3, or some similar arrangement. But the opposite is the case. The movements of the sun and moon are fewer than those of some of the planets. Yet these planets are farther from the center, and thus nearer to the primary body than they, as observation has itself revealed. For we have seen the moon, half full, pass beneath the planet Mars, which vanished on its shadow side, and came forth by the bright and shining part. Similar accounts of other stars are given by the Egyptians and Babylonians, whose observations have been kept for very many years past, and from whom much of our evidence about particular stars is derived. A second difficulty, which may with equal justice be raised, is this: why is it that the primary motion includes such a multitude of stars that their whole array seems to defy counting, while of the other stars each one is separated off, and in no case do we find 2 or more attached to the same motion? On these questions, I say, it is well that we should seek to increase our understanding, though we have but little to go upon, and are placed at so great a distance from the facts in question. Nevertheless, there are certain principles on which, if we base our consideration, we shall not find this difficulty by any means insoluble. We may object that we have been thinking of the stars as mere bodies, and as units with a serial order indeed, but entirely inanimate, but should rather conceive them as enjoying life and action. On this view, the facts cease to appear surprising, for it is natural that the best conditioned of all things should have its good without action, that that which is nearest to it should achieve it by little and simple action, and that which is farther removed by a complexity of actions, just as with men's bodies, one is in good condition without exercise at all, another after a short walk, while another requires running and wrestling and hard training. And there are yet others who, however hard they worked themselves, could never secure this good, but only some substitute for it. To succeed often, or in many things, is difficult. For instance, to throw 10,000 cone throws with the dice would be impossible, but to throw one or two is comparatively easy. In action, again, when A has to be done to get B, B to get C, and C to get D, one step or two present little difficulty, but as the series extends, the difficulty grows. We must then think of the action of the lower stars as similar to that of animals and plants. For on our earth it is man that has the greatest variety of actions, for there are many goods that man can secure. Hence his actions are various and directed to ends beyond them, while the perfectly conditioned has no need of action, since it is itself the end, and action always requires two terms, end and means. The lower animals have less variety of action than man, and plants perhaps have little action, and of one kind only, for either they have but one attainable good, as indeed man has, or, if several, each contributes directly to their ultimate good. One thing then has and enjoys the ultimate good. Other things attain to it, one immediately by few steps, another by many, while yet another does not even attempt to secure it, but is satisfied to reach a point not far removed from that consummation. Thus, taking health as the end, there will be one thing that always possesses health, others that attain it, one by reducing flesh, another by running and thus reducing flesh, another by taking steps to enable himself to run, thus further increasing the number of movements, while another cannot attain health itself, but only running or reduction of flesh, so that one or other of these is for such a being the end. For, while it is clearly best for any being to attain the real end, yet, if that cannot be, the nearer it is to the best, the better will be its state. It is for this reason that the earth moves not at all, and the bodies near to it with few movements, for they do not attain the final end, but only come as near to it as their share in the divine principle permits. But the first heaven finds it immediately, with a single movement, and the bodies intermediate between the first and last heavens attain it indeed, but at the cost of a multiplicity of movement. As to the difficulty, that into the one primary motion is crowded a vast multitude of stars, while of the other stars each has been separately given special movements of its own, there is in the first place this reason for regarding the arrangement as a natural one. In thinking of the life and moving principle of the several heavens, one must regard the first as far superior to the others. Such a superiority would be reasonable, for this single first motion has to move many of the divine bodies, while the numerous other motions move only one each, since each single planet moves with a variety of motions. Thus then, nature makes matters equal and establishes a certain order, giving to the single motion many bodies, and to the single body many motions. And there is a second reason why the other motions have each only one body, in that each of them, except the last, i.e. that which contains the one star, is really moving many bodies. For this last sphere moves with many others, to which it is fixed, each sphere being actually a body, so that its movement will be a joint product. Each sphere, in fact, has its particular natural motion, to which the general movement is, as it were, added. But the force of any limited body is only adequate to moving a limited body. The characteristics of the stars, which move with a circular motion, in respect of substance and shape, movement and order, have now been sufficiently explained. End of chapter 12. Recording in memory of Mitchell Edwards.